I'm going to admit something that's very important. Have you ever had a neighbor that would do just random little things to get under your skin to fuck with you? Have you ever had a person in high school that come up behind you and flick your ear? That's what Anthony Steele is. He's not a bully. He's a pest. I am very angry, not with Anthony Steele. I'm angry with my computer ignoring half the keyboard hits I'm using because it doesn't like the fact that I'm using the mouse on the little trackpad. I'm also angry because I have a damaged arm that won't let me move my arm around. The muscles have nothing wrong with them. It just generates pain unnecessarily. Just getting that out of my system. And yes, I just injured my arm again. I don't need this aggravation, and every one of you that posts anything nasty will be deleted. Don't need a safe space. I just need y'all to listen for a few minutes. And if you're not going to listen, you'll post horse shit and try to drive me over the edge so I'll blow my brains out. That's the purpose of stalkers. Gang stalkers are not anything other than stalkers. Let's move on with it. Bombshell. 5G devices exposes actual beam weapons by DC Dirty Laundry that wants you to know for a fact that they don't give a fuck about facts. So we'll go down and look. Natural News repost. So this website is garbage. 5G LED 450 volt capacitor is an EMP light radiation weapon. So since you've chosen this hill to die on by putting that capacitor into the limelight, I'm going to oblige. LED weaponized street light. Now I wonder what they're gaining from this. Let's look at the next page. The deployment explained. If you're not aware of it, this is a voltage converter board where you can start off with one DC voltage and change it to lots of them, like 5 volts. You know, the things you use for charging up your cell phones. Or, a flashlight. But for some reason, Mark Steele, see the same video, Mark Steele decided to fixate on the voltage rating of a capacitor. So we'll just go look here. And of course, here's your solution to everything. Give us $100 and we'll give you a little green meter. So this one is at 120 volts or 240 volts, maximum 10 amps at 50 or 60 hertz. That means it could do anything from 100 watts, let's say, to 200 watts. No, it's 1,000 to 2,000 watts. So what is it? Well, this, if you can't read, is a switch. That means it can switch on and off up to 10 amps. 10 amps at any voltage, it doesn't care. But it's consuming wattage. No, it's a switch. It's a light switch. But you're not going to listen. That's fine. Some of you are already pre-programmed. There's nothing I can do to save you from this satanic possession you have. So I'm going to move down a little further. So let's go on with the next thing. The video in question is apparently from 2019, November 19th, Mark Steele, or Anthony Steele as his name is sometimes. And it shows him mentioning and obsessing on a voltage on a capacitor. It's a light-emitting diode, light, which is kind of redundant. And this is apparently a light pole light, so it runs off of mains voltage. Now, those of you in the European Union, and especially the UK, know that voltages on your power connectors are specified. So what's the voltage? Now, the first thing he's going to assume is that you don't know what you're going to be looking up here. So I'm going to show you some simple circuits here. But let's get on with why you use a capacitor at 120 volts or 240 line voltage in the UK or whatever the voltage is. Now you can see that dotted line. That's the effect you get when you fully rectify the line voltage, and it comes out as a humming noise that goes all the way down to 0. This is actually right here 0 volts, or very close to it. It's like half a volt. That's about it. Then it goes up here to whatever the peak voltage is for your power line. Now you can look up this information on hundreds of YouTube channels. This is Electro Boom. He's one of, I'm not kidding, hundreds of them. Making a full bridge rectifier. Shows you how to do it. And you might want to watch, because of where he is, what voltage the capacitor rating is. So this is a simplified diagram. First of all, if you're going to plug into 120 volts or 240, the circuit's the same, but you're going to have to get the rating right. So the first part of it is you have to get a connector and you have to have a fuse. Now, most people in America don't know it, but people in Britain are used to replacing the fuse because each cord is supposed to have a fuse in the cord plug, which is ridiculously handy. There's also a main one for the house. It's got a high rating, and then the one in your cord is supposed to be the lowest rating you can get away with. In this case, it's showing a 10 amp fuse because why not? Anyway, the 120 volts comes in and it crosses zero and goes negative. And when it goes through these things, it rectifies it and makes it into that other pattern you saw that goes up over and over again. Now, that peak voltage is what you have to pay attention to. Now, in 120 voltville, like I live in, that comes out to 170 volts DC approximately for the peaks. It's not really, but that's the one you assume. So you have to get a capacitor that can tolerate, in the United States, 170 volts. There's a coil of wire up here to get rid of any radio frequency noises because, like I said, this almost but doesn't quite go to zero. It creates a kind of a choppy noise right at the zero crossing point. So you have to have something that'll filter out that tiny little bit of noise, and it's about 400 cycles a second or 1,000 cycles a second noise. It's called a transition or transient noise. Anyway, this capacitor is a very small one. It's 2.2 microfarad, and all it does is try to get the noise down as well. After that, you usually have another coil, not really much of a useful one, and then a larger value capacitor. If it says it's 2 microfarad, it will hold the power on the power line just a minute, but that's all. But it won't hold it up like this and act like a little battery that gets recharged over and over again every cycle, like it would if it was bigger. Obviously, a bigger battery or a bigger capacitor holds more power for a longer period of time. So what happens if you double your voltage? In Britain, they use 220 or whatever. But anyway, the basic voltage on the output of a full-wave rectifier in Britain would be around 340 volts. Now, there's this thing that you may not like. That means that peak to peak, if you fold the waveform, it's 340 volts. It really is. It's called root mean square, or RMS. The RMS voltage is actually lower. It's like 2 something. But the real voltage coming out of the line can be a lot higher. And it really is 340 volts peak. It goes peak to peak 340. But if you take all those wave shapes and average them out, it works out to effectively being as good as what would be a DC 240 volts or something like that. So now we get to the standard aluminum electrolytic capacitor standard for filtering in Britain that's used in every circuit. You may have noticed the fucking voltage is 450 volts, but there are alternatives. You can have 400. But the voltage has to be above 340. Now, why would you do that high? Let's try a simple rule here. Now, this may not work out. Times 1.5. This is fudge factor. Assume a fudge factor of 50% for safety. We should be putting in 510 volt capacitors. Now, what is this actually? So let's go. Obviously, that was 370. So, what was it? 450 divided by 350. What is the fudge factor used in those circuits? It's 28%, 29%. So let me review with you. The idea is that the capacitor has to be a higher voltage than your line voltage. And in this case, in case you can't figure out why it's such a simple thing, instead of actually doing RMS and all the mathematics, they just said if we're rectifying, effectively 220, 240, why don't we just use a 400 or 450 volt capacitor and be done with it? It's whatever's on the shelf at the time. If it's too low, you'll use the next one up. That way it filters the noise out so you don't get radio frequency noise. They're only good for 2,000 to 1,000 hours in this ad, but they're actually much better than that. So why would somebody use this supposedly very dangerous 450 volt capacitor? Excuse me, I almost said battery, because it functions as one between the pulses. You notice there's 68 microfarad. That's pretty common, but they also use larger ones that can be up to 300 microfarad or even 1,000 microfarad, depending on whether or not it has to hold a lot of current. You basically put a big enough value for the farad value for it to fill in the spaces enough that it doesn't make any loud noises or make it hard for the circuit to work. So let's read those videos. Let's go all the way to the top. So we go down here slowly. So what is this circuit? Well, I don't know or care if he actually explained it, but it's a light emitting diode that's running at lines voltage or mains voltage. And it has to be turned to DC because LEDs are DC based. It doesn't have to be very good because these parts here indicate a switching circuit. And let's go back up here, all the way up here. There we go. And in case you didn't notice, if you get a switching circuit that runs at a high voltage, it can use a very low current to switch on the same amount of wattage. If it's 100 watts and you feed it 100 volts, you only have to control 1 amp of current. So that's what the switching circuit is for. This kind of switching circuit is found in every laptop, desktop, every one of your pieces of equipment. And in one country or another, if your voltage is different, you're going to have a filter capacitor, these big fat SOBs here. They're going to be one voltage or another. And 450 volts or 400 volts is enough, mostly, to tolerate it to be not so low. If it was a lower voltage than that, the mains voltage would cause them to be overloaded a bit. It would age them quickly, or they would just not work, and it may actually be dangerous. So why is this person who's claiming to be an expert in all these subjects not explaining to you something you can look up on a YouTube channel called Electroboom on how full bridge rectifiers work? In fact, this is actually an in-joke on his channel. Full bridge rectifier. So you tell me. Now remember, we started off with 120 volts. This turns into 170. Okay, what if we use the British standard he's looking at that he doesn't like that says 450? Well, we would end up with a 225 capacitor. You know what? There might be something similar to that in most connectors in the United States as far as rectifying and cleaning up the power. Next, that fudge factor there I wouldn't use. I would use a higher voltage capacitor than that. But I don't know. You tell me. So to review, Mark Steele is not doing you any favors. He's not telling you any truths. He's not helping you learn anything. People keep re-uploading this thing. I don't know why. It doesn't give you anything to benefit from. Mark Steele's video going off on a tangent about the voltage on a capacitor and not letting anybody talk about why it's that voltage. It's that voltage because that was the one that was in the box for the design. It works well enough. Is his complaint that 450 volt DC being a capacitor is somehow dangerous? Because it's acting like basically a little battery riding the power wave to make sure it gets rid of the noise. If it wasn't there, it would be noisier and harder to clean up and harder to use to run the lights. They might even flicker. That's what it's for. And every single electronics engineering technician you run into will explain that to you. It's not that somebody's being fooled by it. It's not that there's some giant conspiracy. It's not that all of us have been taught something, the world's been pulled over our eyes. It's that you're arguing with a bunch of people who can literally sit down and build this and prove to you that it works a certain way, and that there's no actual purpose other than to filter out the noise. Sort of like me this week. Why would you listen to this buffoon, this fucking orangutan, lie to you? I want to know why. Anyway, I'll keyword the hell out of this video, and you can flag it at will. Thanks for watching. Have a good day. Good luck with that. And Mark Steele is literally hoping you don't look up things. You can fact check me. Will he let you fact check him?